Tarot and COATLI telescope, COATLI, compilation of early optical photometry of GRBs. Rosa, you can share your
thing. Could you see them? No.
Yes.
Ah, okay.
Yes.
Well, hello, everyone. I'm Rosa Becerra, and I said on Tuesday, and I'm doing a postdoc with Fabio De Cole in the UNAM, in the Instituto of Ciencias Nucleares. In my free time, I organize conferences. And here I'm going to talk about a project which is developed mostly with Alan Klotz. First, I want to give you a briefly outline about the talk. First, I will present the introduction and the methodology, then the results, and finally, why is this connected with Colibri and why we are here. Listen me. Why this work is important to the science. I want to mention the participants of this project, and I'm very happy because most of them are here. Like I said before, I spent 2 weeks last year with Alan Klotz to prepare this work. And also I contact Daphne Guetta, who is a very good cosmologist. And also I work with Alan Watson, Fabio De Cole, who is my boss, with Jean-Luc, Eleonora, Nissim, William, and Nat. Thank you very much for your cooperation. I think that the GRBs were widely discussed yesterday, but I just want to mark here that what we know about the optical counterpart of GRBs comes the fact we are trying to explain why, from where this comes. Could be from the internal shocks and could be due by the tail of the prompt emission, or could be from the afterglow as the radio frequencies. But what we do know is a lot of things. We don't know if all GRBs have an optical counterpart. If we don't observe that, is because it's something extrinsic because of absorption, or is there an dark GRB and is something intrinsic. Typically, we invoke the synchrotron emission to explain what we are seeing, not just in optical, but also with X-ray and radio frequencies. But we are not very sure in several cases if it's only if it's the only radiative process involved. And like it was very discussed yesterday, we don't know how important are the magnetic fields or not to produce the jet, or if there is a leptonic dominance and we don't observe a reverse shock, or we expect a more canonical behavior. Also, I did this work because I tried to answer the question, how many of GRBs have some interesting features, like a reverse shock, a late central activity signature, a flare, and finally, and this is for my theoretician friends, because they always ask if there is a GRB, a canonical GRB, and the answer, of course, is not. And thanks to many of these questions, most of us are here trying to answer them. This work was done with the database of Tarot, the toy of Alan. Tarot has 3 three telescopes around the world, one in France, another in La Silla, Chile, and the last one in España. And we have my baby, Coatli, and Ratir in Observatorio Nacional de San Pedro Mártir in Mexico, of course. They are optimized to catch the early optical counterpart of some transient and specifically GRBs. Then what we did, well, I asked to Alan to provide me all the data from Tarot, and I have the COATLI data, and what we did was to put them at the same corrected by the cosmological effects and also the absorption, and we plot them here. You can see we have also upper limits, but in the most of the cases we have a beauty light curve. And when this is the orange and the purple and are unpublished data yet. And when I did that with Alan, we decided to look for the X-ray counterpart of this event in order to compare what we are seeing here. And also we did the same with the data to correct them by cosmological effects and to compare. And first, I want to show you the first result, which is the canonical light curve that I obtained. You can see here, this is my result. This is, we average all the light curves in several beams of time. And we did the same in X-ray. You can see here, this is multiplied by a factor just for visual reasons. And you can see here, this is what the theoretician predict. And for example, here is a picture from 6 years ago. This is very, very similar qualitatively to my result. You can see here the end of the prompt emission, then a little plateau with the presence or not, or a flare, and then the normal decay that we expect, and then I didn't. And for the optical, this is more interesting for us because you can see here first the number.
Rosa, you have 3 minutes left.
How many?
3.
Pero era de 15.
15 minutes.
Oh, sorry. So you have 3 plus 5, 8.
So sorry.
No, okay.
What I want to mark here is the number of GRBs that we have at this moment, because 8 years ago we only had 150 events, but then the specific characteristics are very uncommon in this case, but this is for the lack of early observation, not because the GRB didn't present them. And this is first is what I want to conclude in this part, because you can see here the most of the light curves are not in the average, are up, or this is the average. This is a plateau, a common plateau, but these points are above the average, and this represents some presence of reverse shock or optical flares. Also, what I did with Alan was to make a luminosity function, and we plot the apparent magnitude after 1,000 seconds after the trigger, and we compare the apparent magnitude. We did an histogram and the cumulative histogram, and then smooth the light curve in order to obtain synthetic population of GRBs. We did the same for detection and upper limits because we want to compare with another results. And what we obtain, this is a very common behavior for a luminosity function like the Schuster that is very common in galactic field for the person who studied the galaxy. And here I want to conclude that this is these results is constrained by our limitation because of the telescopes and the optic of them. And then with Daphne, I did this beautiful picture. Daphne works doing a population of GRBs, and she studies the behavior of the events in relation of the redshift. And we plot here an histogram of the number of GRBs that we have with certain redshift. And here, this is the cumulative cure. And here, this is our best fit if we take into account all the GRBs. And this is, well, this is the result. This is a real result. But if you, you could see here that for the closest GRB, we have a lack of events compared with the reality. And this is because we are not really well sampled high redshift. But if we only take into account the number of redshift with a smaller redshift, we can see here that we fit very well the closer events, but here we have a lack in the further GRBs. And this is explained because, again, our telescopes cannot be used to observe larger distances. And just to give you numbers, this number refers to the rate of GRBs at Z equals 0, and the number of the total GRBs is around 0.5. But if we only take into account the GRBs observed by telescopes like COATLI and Tarot, we only have the 6 or 5% of all of them, and this is very poor. This is why this is why I want to that you keep in mind this number and this plot.
You have 3 minutes now.
Okay. Then I just want to conclude the work. I show you the canonical Lie curve, and we are very far from a canonical GRB, and it's impossible to say how the GRB is going to be before. And some interesting features like flares, reverse shock, and plateaus are more common than we expect. And we can fit all my GRBs with a Schuster function, and we see a maximum around a magnitude 18 after 1,000 seconds of the trigger. And I think that the most important result here is to show that we are very good. All the telescopes in ground are very good in a small distance, and from the total of GRBs, just the 6 or 5% have an early optical counterpart. Here is when I want to link with this conference, because Tarot and COATLI are not so different of another telescopes, ground telescopes, which follow GRBs, but typically we reach in individual exposure and magnitudes around 18. And this is why this sample could be with a bias. Also, we don't have the redshift for many of them, and we cannot say a lot with a small percentage. We need to increase our sample. And of course, we are close because of COVID, but in the future, we need to increase our sample just to see what we are doing and if it's good or not. And all the models that are already done is typically for redshift, which are very close. And I think that this is a very good punch to say that Colibri comes to change all of this. Finally, I want to thank you. Merci beaucoup pour votre attention. Et c'est tout.
Thank you very much, Rosa. So now people are wake up. So there are many questions. So there are 3 questions. First by Damien. Can you ask your question, please?
Yes. Okay, in your slide number 10, it's just a curious question. You have a gap between the detection and
Yes.
upper limit luminosity function compared to the Schechter luminosity function. How do you explain this gap?
Yes, I think that this is maybe
15, sorry, 16 or 15.
Yes, I think that this is maybe because of the performance of Tarot and COATLI, because they don't agree or don't have the same magnitude limiting magnitude, and I think that this is an effect. I can see you.
Jean-Luc, your microphone.
I only can see my slide, sorry. I cannot see you.
Yes, so I was saying that there are many questions. Fernanda, I ask you to ask one of your 2 questions, and then there will be the question by Diego, and then we will stop, okay? So question by Fernanda, question by Diego, and then we stop the questions.
Okay, thank you. Well, thank you, Rosa. Your presentation was awesome. Yeah, I think that my first question is a little bit related with the one from Damon, so I will ask the following one. So in your 8th slide, comparing the theoretical Lie curve that you shown, yes, against your results, it seems like there is a supernova bump in the optical curve. Are they related, or is it's only my brain thinking about that?
No, if you see here, I am only show the early times, and the supernova appears after 6.1 days.
Sorry,
It's not,
yeah, the time I can see the axis. So, okay.
Don't worry.
And last question by Diego.
Yeah, so in this slide, what I didn't quite follow is, so the components that you said in X-ray, that you said that there was like that plateau and maybe a flare, and then, so how consistent are the components that you see in X-rays with the ones in the optical light curve? Or are they completely different?
No, they are very similar. Now, you can see here, there is a plateau and maybe with a lot of.
Where is there a plateau there? Maybe my non-observational eyes cannot.
I didn't isolate the presence of a flare here and also here.
Okay. Okay.
I can show you.
No, that's fine. Just so there is a flare in both.
Yes, but also we have here a rubber shock, which is not present in X-rays, for example.
Okay, so the consistent things are flares in both, and that's the rest, and that's all.
Yes.
Okay, thank you.
Okay, thank you, Rosa. I propose now to switch to the talk of Damien Turpin about